Before we look at some typical proof questions, we're going to talk about the terminology and the facts that you need to be aware of to be able to do these proofs. So they use the letter N a lot in proofs. N is just going to stand for any integer, and remember, integers are just whole numbers. So if N is an integer, then 2n would be an even number. Think about it. Definition of an even number, it divides by 2. And if an even number is 2n, then an odd number will be 2n plus 1. So an even number plus 1 will always give you an odd number. So this is how we algebraically show an even number and an odd number. Another term that you need to be familiar with is the word consecutive. So consecutive numbers are numbers that follow each other in order without gaps. So for example, 4 is followed by 5. 112 would be followed by 113. Minus 5 would be followed by minus 4. Think about it. More things that we need to know and understand or be familiar with, because these kind of things come up a lot. So an even plus another even, it always equals an even. So how do we prove this? So we know that even numbers are written as 2n. So if we've got 2n plus another 2n, if we add that together, we get 4n. That is the same as 2 brackets 2n, if you like. So if you multiply any number by 2, as we discussed earlier, you get an even number. So this is going to be even. We start with 2 odd numbers, so 2n plus 1 plus another odd number 2n plus 1. We add that all together, we get 4n plus 2, and you can factorize that again. So if we bring out the 2, we get 2n plus 1 in there. So 2 times anything is going to give you an even number. We're talking about integers, obviously, not decimals. So that's even. Now if we have an even number plus an odd number, then that's going to make 4n plus 1. So we've already shown at the top there that 4n is an even number, and we've discussed that if we just add 1 on, then that will turn it into an odd number. So you may not necessarily be asked to prove these things, but sometimes you might need to think this way and use this to help you prove something else. So an even number is 2n. If we multiply it by an even number, we're going to get 4n squared. So that's 2 brackets 2n squared. So that's even. Odd would be 2n plus 1 times by 2n plus 1. Expanding those brackets, we're going to get 4n squared plus 4n plus 1. So I've shown up there that this is even and this is even. We showed that right at the beginning. And we showed that 2 even numbers added together are even. And then if you add just 1 on the end, then that turns it into an odd number. So then if we've got an even number times by an odd number, if we multiply that out, we're going to get 4n squared plus 2n. And you can factorize that, so we get 2n squared plus 1n, which we don't write the 1 obviously. And so again we can see that that's going to be an even number, Just a few more thoughts to help get you into the mindset, and then we'll do a proper question. So what is the next consecutive even number after 2n? Going to be 2n plus 2. Think about the pattern that we've got of our even numbers. So you've got 2, 4, 6, 8, 10. And if you think about it like a sequence, what's happening every time? You add 2. So the next even number after that would be 2n plus 4. So in a similar fashion, what would be the next odd number after 2n plus 1? So thinking about your odd numbers, what you'll see is there is also a plus 2 pattern going on here. So the next odd number after 2n plus 1 would be 2n plus 3. So it says prove algebraically that n minus 5 in brackets squared minus 2n minus 1 in brackets equals n minus 3 times n minus 9 minus 1. So to do a proof like this, you take one side and you turn it into the other. So we're going to take the left hand side and turn it into the right hand side. So we've got n minus 5 squared, which means n minus 5 times n minus 5. So if we expand that, we're going to get n squared minus 10n plus 25. Now we've also on the left hand side got minus 2n plus 1. So when we remove that bracket, we'll have minus 2n and plus 1, minus 1. So altogether on that side, we've got n squared minus 12n plus 26. So this is where we're going to be a bit cunning. We can see what's on the other side, and we can see that we want a minus 1 left over. So to make this look a bit more like that, you see what I've done? So 26 is the same as 27 and minus 1. So now I've got on my left hand side this part of the right hand side. So all I've got to do now is prove that this section here, when it's factorised, is the same as above. So it's n squared, so it'll definitely be n and n, and we've got 27 at the end. So it very definitely could be 3 times 9 to get that. Does 3 and 9 make 12? They do. And so minus 3 minus 9 pops in there. So we have turned the left hand side into the right hand side. Therefore we've proved that they are the same. Now we're going to use some of that knowledge that we had before to do this sum. So it says prove algebraically that the sum of the squares of any two consecutive even numbers is divisible by 4. So let's read that again. The sum of the squares of any two consecutive even numbers is divisible by 4. So first of all, two consecutive even numbers. So if that's our first even number, we know the next one looks like this. Now it wants us to square them and add them together. So we need to do 2n squared plus 2n plus 2 squared. So let's remove those brackets. So we'll have 4n squared here, and over here we will have 4n squared plus 8n plus 4. So let's tidy that all up. We're going to get 8n squared plus 8n plus 4. Now they want us to prove that this can be divided by 4, and the way you do that is by factorising out 4. So this would leave us with 2n squared plus 2n plus 1. So 4 times something that would be a whole number is going to be part of your 4 times table, and therefore you can divide it by 4 and have a whole number answer. And so that's proved. Final one. Prove algebraically that the difference between the squares of any 2 consecutive numbers is always odd. So this time we've got 2 consecutive numbers. So if our first number is n, the next one would be n plus 1. We still need to square them, but this time we're going to take them away. So we put the big one first as normal. So n plus 1 squared minus n squared. So n plus 1 squared will be n squared plus 2n plus 1. And then we've got to take off the n squared. So that means we'll be left with 2n plus 1, which we know is always an odd number.